Welcome to GMAETS 41's chemistry class. In our class today, I was just going to talk about how terrible network is tonight, and that I was going to regularly go to check, the camera to see whether you friends are still connected, as to whether the network is still cool for us to be going. But not knowing that the network are just interrupted. You see, so we're going to just really manage. It's going to be a quick class because, like I said, the network isn't fair. I don't even know if the network has gone down as I'm saying this now. Okay? So please, let's just see how far we can go. This class focuses on calculation of oxidation number. When you pronounce a compound, the name of the network is so terrible. The network is extremely terrible tonight. Extremely. I just hope to do something, but I will go to the board now. And if the network still interferes, I will stop this class for today. I'll stop it for today. Tomorrow is Thursday. And then I could see if I'm not able to hold it on Thursday, then on Saturday, we would hold this class. So I'll go to the board now and then continue with what I want to do. I'll come back to the camera and still check. If the network disturbs again, we will pause this class for today. The network is really very bad. So I was saying that before a student can move on into calculating oxidation number of any element in a compound, there are certain things you should know. Number one, the oxidation number of a single element is 0. An element that has not reacted, the oxidation number is what? 0. For example, if I give you hydrogen, say what's the oxidation number of hydrogen? The answer will be 0. Oxidation number of sodium, the answer will be 0. Oxidation number of chlorine, the answer will be 0. If it is standing alone on its own. Are you following, right? Then also the oxidation number of a whole compound, like we have this. The oxidation number is also equal to 0. The oxidation number is also equal to what? 0. So having this in mind, it will guide us to know how we solve questions regarding oxidation number of any element in a compound. So let us see how we solve this. There is nothing in it. Once you have excellent knowledge of valence electron, your problem is solved. Because we need valence electron to guide us in dealing with this. So perhaps let me give you the formula you apply to determine the oxidation number of any element in a compound. All you have to do is to take the summation or algebraic sum of the product of the valencies, all right, of each element in the compound with the atomicity. Then equate everything to 0. What do I mean by that? Simply operate using summation. This summation means add. Add the valency. Valency, that is summation of valency of each element. Valency of each element times its atomicity in that compound. Times atomicity in the compound. I'm abbreviating compound to be this. Then equate it to 0. Once you apply this formula, you can actually get the oxidation number of any element in a given compound. One thing you want to bear in mind is, if you are asked to find the oxidation number of any element, that particular element, the valency will be taken to be an unknown valency, because that's what you are looking for. It is the oxidation number of that guy you are looking for. Like in this question 1, we are asked to find the oxidation number of carbon in calcium triazocarbonate something, CaCO3. Are you following, right? Since you are looking for the oxidation number of carbon, therefore means that the valency of carbon will be unknown. Then applying this formula, valency of each element times atomicity of that element in the compound. Take the summation. This symbol means to add up everything. And then equate to what is to 0. This is for a given compound. So let us apply this and see. I'll come to calcium. Calcium is 2 plus the valency. We've treated that. Carbon, we don't know the valency. We don't know the valency. That's what we are looking for. oxygen with its 3 atom there, the valence of oxygen is what? -2. Please let me check the network situation quickly. All right. Okay. The network is there. So it's like your mic is not connected. That's serious. That is serious. I can't hear well. Please, Chinedu. Okay, you can hear me now, right? Okay. I think the network is still carrying us on, so let's continue. Sorry about the mic something. Oh my God. I think I might still run down through these once again, since you said that you could not hear me earlier. Since you say you could not hear me earlier. So we are saying to determine the oxidation number of any element in a compound. First of all, remember that the oxidation number of a compound is equal to 0. The oxidation number of a compound is equal to 0. This is a compound. How do we know that this guy is a compound? See, there is nothing like plus or minus here. So it's a compound, not a ion. The oxidation number of any compound, the compound as a whole, is equal to 0. So to calculate the oxidation number of any element in a compound, simply use this formula. This sign you're seeing here, this symbol, means summation, addition. You are expected to add valency of each element times its atomicity, which means you come to element this, the valency multiplied by its atomicity. Go to the other element, the valency multiplied by its atomicity. Do it for each of the elements in that compound, then add all of them together, equates to what? 0. The particular element whose oxidation number you are looking for, you will take its valency to be an unknown alphabet. In this case, like for carbon, I'm using X. I decided to show you this because you need to know each of their valencies before you apply this formula. So this implies that coming to calcium, the valency is 2. It is going to be 2 times the atomicity of calcium in this compound. Calcium here, the atomicity is 1. I've explained all of these in our previous class. I am going to add it. Remember, we are doing summation. So you add to the next one. Come to carbon, the oxidation number you don't know. The oxidation number is playing the role of valency in this case. So you come to this guy, X, multiply by its atomicity, because here the valency of carbon is now going to be an unknown alphabet for us, an unknown. It's going to be an unknown, which I use alphabet X to represent. Multiply by its atomicity. The atomicity of carbon in this compound is 1. Again, add it to that of oxygen. Apply this formula again on oxygen. Valency of each element. In this case, valency of oxygen, which is -2. Multiply by the atomicity of that oxygen in this compound. So that's going to be -2 times. The atomicity of oxygen, you can see, is 3. Look at it here. In calcium trisulcarbonate. All right, so equate it to 0 now because this is a compound. So all you have to do is just to solve this simple equation. And then you calculate the value of X. Let me check the network situation. I'm very concerned about that, to be sure that we are following. Good. So with this, simplify this. 2 times 1 will give us 2, plus X times 1 will give us X. Come here, -2 times 3 will give you -6. Plus times -6 is -6. Then equate it to 0. Work on these like terms here. 2 and -6, they are like terms, and they are on the same sides of the equation, so you can simplify them. 2 minus 6 will give you -4. So you have your X here, then 2 as a pure number, -6 as a pure number, they are like terms, so you can simplify that, you get -4. Equate it to 0. Therefore, X is equal to what? 4, because this -4 will cross. If it crosses, you have 0 plus 4. Let me use it implies. And then we conclude that X is equal to what? 4. So look at this X here, the oxidation number, the valency per se of carbon in this compound is 4. So we can conclude the oxidation number, therefore, oxidation number of carbon in CaCO3 in CaCO3 equals 4. That is the answer. That is the answer. So you see, it is pretty simple to calculate oxidation number of any element in a compound. Nothing is there. It's 1 plus 1 work. All right, still checking the network. Please, once you join this class, like this live class and quickly help me to share this link to your friends. If you belong to any science group, share this link to that science group. Somebody there needs this class. As a matter of fact, based on the testimony I usually receive from some of you friends, are you following? There are some people that just connect this class and they get to meet something that perhaps the next day being tomorrow, they need that knowledge. So share this thing to your friends, this class, share the link to your friends, invite them to join the class now. Also encourage them to subscribe. If you are connected to the class and you have not subscribed, right away as I am speaking with you, please subscribe now. And once you subscribe, don't stop there. You will see a notification bell, a bell icon. Tap on that bell icon, a menu will pop up. Select all. Select all. The reason for that is so that you can follow up with our updates on this channel. We have classes on Mondays, on Wednesday, on Friday. I come on live to teach you, friends. Are you following? Physics, chemistry, maths? So if you don't want to miss out on any of these classes, then you have to turn on your notification bell and select all. Once the class starts, YouTube will send you a notification immediately. If I didn't before then. All right, we are done with this, please. Let's move on to the next question. Question number 2. Question number 2. Thank you so much, Chinedu, for helping me know that network is cool there. I appreciate. So don't forget this formula. Copy it very quickly. Valency of a particular element times the atomicity of that element in the compound. Do it for each element in that compound, add all of them together, equate it to 0, and then calculate for the unknown oxidation number. Oxidation number is just something that it serves the purpose of valency. So you have to calculate the oxidation number of carbon in this compound. It is simply the same as maybe find the valency of carbon in this compound. But it is not always all too easy to think that it is the normal valency of that element you know. It is not all too easy to think so. Yeah, we know that the valency of carbon most generally is 4. But there are cases that the valency of carbon may not be 4. There are cases that it may not be 4. What of a case where that carbon reacts? Are you getting me right? So that is why you should know how to calculate oxidation number. That is why you should know how to calculate it. Very important. Let's move on to question number 2. You can see, give me the formula you use, and with this formula, I think that's all. I'll wipe this. Perhaps, let me give you this particular guy now, so that you understand what I mean and appreciate it when I say you have to know how to calculate oxidation number. Because it is not in all cases that the oxidation number will be the same as the valency of that guy exactly. It is not in all cases. Let's look at this second question. Meanwhile, for this guy, we calculated and got 4. That is why that is the oxidation number of carbon we calculated in CaCO3 to get 4. That is why if you are pronouncing this compound, CaCO3, you start with the first element, pronounce it fully, which is calcium. Go to the last element, pronounce its atomicity using Latin representation of that number. 3 here is tri. So it now become tri. You come to this oxygen, you pronounce it oxo. Change the prefix to oxo. Right? And then you come to the middle element, carbon. You now pronounce it carbonate. Change the suffix to 8, carbonate. And then you conclude with 4. So you now see how that 4 came about. Calcium trioxocarbonate 4. Question number 2. Calculate the oxidation number of carbon in CO. Look at this compound. Let me check the network situation. Good. The network is still there. What grade is this? Jared Vasi. What grade is this? All right. Jared Vasi, this class specifically targets those in grade 10, right? But this is science. So grade 10, grade 11, grade 12, university, 100 level student, and those that study pure chemistry, industrial chemistry, they need this. Are you following? So let us say from grade 10 to university, they need this guy. They need it. If you are aspiring for 100 level, I tutor 100 level student as well too. At Nnamdi Azikiwe University, Oka. You will meet this in your Chem 101, basic inorganic chemistry. You will meet this. So it's not a matter of, okay, particularly once you are in senior level of learning in secondary school, that is high school, in college, in university, you need this guy. Oxidation number of carbon in this compound. So what do we do? Remember the formula. Use the formula summation. Must I write the formula? It's not necessary. I've written the formula already, so I guess you should have it. Let me bring out CO. This carbon, we are calculating the oxidation number of carbon in this compound, CO. So the next one is oxygen, O. I have to write the valency of oxygen. Oxidation number of carbon is what I am looking for. So it becomes our unknown. This is a compound, a full compound. Yes, it's a binary compound. A binary compound. How do you know that this is a compound? There is no ionic charge here. Nothing like plus, nothing like minus. Therefore, it is a compound. Of course, that is how you identify a compound. I know a compound is a substance form when two or more elements, that is when two or more atoms of a particular element or different element rather combine chemically. Simply put, when two or more elements combine chemically, you get a compound. When a compound is formed, there is nothing like plus or minus on it. You won't see anything like that. So take note. CO is a compound. We are asked to find the oxidation number of carbon in that compound. So since we don't know the oxidation number of carbon, we fix X there. Move on to oxygen. Write out the valency of oxygen. Then from here, you use the formula summation. Valency of each element times its atomicity in the compound. Equate it to 0. In this case, I'll come to carbon. The valence, as you see here, is X times 1, which of course happens to be the oxidation number we are looking for. Why is it times 1? The atomicity of carbon in CO is 1. I've explained all of this in our previous classes, right? Move on to oxygen. The valency is minus 2 multiplied by 1. Why again are you multiplying by 1? The atomicity of oxygen in the compound is 1. Equate it to 0 because the addition, the sum, the total oxidation number of a compound, like I said before solving question 1, is equal to 0. In exam, an examiner can ask you, what is the oxidation number of, and a full compound will be given to you. Let me assume, what is the oxidation number of lithium tetrahydridoaluminate 3? That's a full compound. I showed you how it is formed from our previous class. The answer is 0. Because that's a compound, and the oxidation number of a compound, like I said, is what? 0. I keep emphasizing on this because you need to know it so that whenever you are solving the oxidation number of any element in a compound, by the time you have applied that formula, multiply the valency by the atomicity, add them for each element. The next thing you equate it for what? You equate it to what? 0 for a compound. From here we have X minus 2. No time to waste. Minus 2 times 1, we give you minus 2. Plus times minus 2 is minus 2, and that's equal to 0. Therefore, X is equal to 0. Now, X is equal to 2. Because this minus 2 will cross. You collect like terms. This is a pure number. 0 is a pure number. Move minus 2 from the left-hand side to the right-hand side. Add it to this 0. You get 2. Do you see? In CaCO3, oxidation number of carbon there was 4. In this compound CO, oxidation number of carbon is what? 2. All right, we have solved the oxidation number of carbon in CO. That is why, in pronouncing this compound, the name of this compound is carbon 2 oxide. Carbon 2 oxide. If you are writing it fully, it's meant to be written this way: carbon and then 2 oxide. That 2 is written in Roman figure, Roman numeral. That's the rule. It is just like that calcium triosocarbonate 4, question number 1. That 4 is written in Roman numerals, IV. Carbon 2 oxide. This is that compound called carbon monoxide. Carbon monoxide, due to incomplete combustion of certain organic substances. Let me check the network situation. Okay, the network is still on. So, is this helpful for biochemistry? I am planning to take the biochem degree within the next year. I am changing from biophysics. Mr. E, yeah. All right, answering your question. The answer to your question is yes. This is useful to biochemistry. Biochemistry is a science course. It's a science course. And the last time I checked, as long as you're passing through 100 level, you will study this in chemistry. You will study it in chemistry. Okay? So it is useful to biochemistry. One good thing about all these things, let me tell you now, basic subjects in secondary school. In your university work, it's the subject you build on. As a matter of fact, 80% of the knowledge you gain from your secondary school work, your high school work, you need them in your advanced level. You need them. So, yes, once again, to your question, this is useful to biochemistry, to all medical fields. Number 1, all biosciences, all physical sciences, all engineering. Because engineering students also, I guess in the 100 level, they are being introduced to chemistry. Please, we are moving on. This is question number 2, having been solved. Let us now move on to another question, number 3. Now, wipe this one. This is interesting. This is interesting. Why did I say it is interesting? Any other thing you do from here with regards to calculating oxidation number, you are simply repeating the same thing. I repeat, you are simply repeating the same thing. The secret to this calculation is having excellent knowledge of valence electron, because valence electron is what gives us the idea of valency. And you see that in the formula for calculating the oxidation number of any element, you need valency. Remember where we started, talking about the importance of valence electron. So just see, since this should be the 4th or 5th, the 4th class, I guess. Since we kick-started our former online classes from the beginning of this September, from the beginning of September, that was last month, because today is October 1 now. This is the 4th week. You see, everything we've been seeing as topics in chemistry, the knowledge of valence electrons, it's what is guiding us to learn them. Question number 3. What is the oxidation number? What is the oxidation number? Oxidation number of manganese. Manganese in KMnO4. This compound, KMnO4, is a strong oxidizing agent. All right. What is the oxidation number of manganese in this compound? Let's find out. Solution. Bring out the elements of this compound respecting their valencies. Potassium has a valency of +1, so just plus. We are calculating the oxidation number of manganese in this compound. Therefore, I am going to, let's use Y this time around. Let the oxidation number of manganese be Y. You can use X, you can use any other alphabet, the choice is yours. Then oxygen, the oxidation number is 2 minus. And the number of atoms of oxygen in this compound is what? 4. Applying our formula. Do you still remember that formula? If you do remember, tell me. Tell me, I can feel it from here, okay? Tell me. The formula you use in solving for the oxidation number of an element in a compound. That's good. Simply take the sum. Take the sum. Add up the product, the multiplication of the valency of each element by its atomicity in that compound, then equates to 0. Let's do that and see. Potassium here, the valency, of course, is 1. Multiply it by atomicity of potassium in this KMnO4, which is also 1. Now, add it up to the valency of manganese here, which is the oxidation number we don't know, is Y. Multiply by its atomicity in the compound, which is 1, because manganese is 1 atom here. Mn, 1 atom. Plus, come to oxygen, the valency is minus 2, multiplied by the atomicity, which is 4, and then equates to 0. Solve for Y. This is going to give us 1 plus Y. If you solve out this, you get minus 8, equates to 0. On the left-hand side of the equation, you have this as a pure number, you have this as a pure number, so you can simplify them since they are like terms. 1 minus 8 will give you minus 7. So you now have positive Y, which is Y. Then minus 7 equal to 0. And what do you see? Therefore, Y is equal to what? 7. The oxidation number of manganese in KMnO4 is plus 7, or simply 7. It doesn't matter. You can use plus 7 if you want. There are some you might calculate and you could get negative. In the case of negative, you put that minus. Remember, you don't play with minus anyhow. Minus is not our mate. That guy has this strange behavior. Imagine minus times plus, we give you minus. Minus times minus, that you could expect, okay, these are just minus, minus. You should maintain minus. It will just change it to plus. You see? So it is not our mate. But plus, yeah, if you like, you can put the plus. If you don't like, you leave it. If you write any number on its own without any sign, it is assumed to be plus. So this is the oxidation number of manganese in this compound. No wonder. In pronouncing this compound, the name is, this is a trinary compound. We treated it in our previous class, I think on last week, Wednesday, our chemistry class. Pronounce the first element fully. K is potassium. Go to the last element, determine the atomicity, Latinize that atomicity. The Latin word for 4 is tetra. This oxygen, the prefix, the beginning part, change it to oxo. Come to this middle element, which is manganese. Change the suffix to 8. So it becomes manganate. You conclude 7. And this 7, if you are writing the name in word, the IUPAC name of this in word, that 7, remember, is written in Roman numerals, VII. So this is potassium tetraozomanganate 7. Now let me shock you with something again. Does it mean that the oxidation number of manganese is 7 always? Wherever you see it? Let's find out in this next compound. Copy this as I check the network situation. Please, as you join this class, like this class. Give it a like. Give it a like. Very important to me. Like what is happening here. Or what I'm doing. Is it something wrong? Is it something wrong? I guess I'm really giving a lot. Not just to my nation. Right? Not just from where I came from. Not just to my country. But to the world. Like this class. Share the link to our videos to your friends. Encourage them to join, to your neighbors. Let's push this channel because a lot of academic wonders are taking place on this channel. Please, I'll appreciate that. So once you don't just connect and you're looking, Once you connect, like, whether or not you are offering this subject, like what is happening. Like what is happening. Or is it when I come online and start doing rubbish that you like me? Of course, I will never do that. I won't. All right, let's move on, please, to the next question. Still maintaining that manganese, and now look at what we're going to have. This compound, let us calculate the oxidation number of manganese in it, MnO2. And let me tell you, the oxidation number of an element in a compound actually can be solved without stressing yourself to calculate anything. Activating the network of your brain and being good with your multiplication, you can actually get the answer without wasting time. Like here, for example, since we are looking for the oxidation number of manganese, manganese valency will become the unknown. Come to oxygen, the valency of oxygen is 2 minus. Multiply that 2 minus 2 by the atomicity, which is 2. This guy is going to give us Mn to be equal to what? That is the oxidation number of manganese here to be equal to 4. Which means that this compound is manganese 4 oxide. Anyway, let's solve it together. Manganese, we don't know the oxidation number. Let me use X to represent it. Oxygen is 2 minus. In this compound, it has an atomicity of 2. So here, you're going to... Seems like the network interrupted. So I just tried to boost it. We are done with this question number 4. So the oxidation number of chromium in this compound is 6. 6. Let us move on. With this, we have actually come to the end of oxidation number calculation for compounds. How about how to get the oxidation number of a particular element in a particular ion, rather, how to get the oxidation number of a particular element in an ion. How about how to get the oxidation number of a particular element in what? An ion. We've dealt with that of compounds. So imagine your examiner refuses to now give you question based on oxidation number of an element in a compound. Instead, it is given in terms of ion. How do you solve it? Let's move on to question number 5. Question number 5. Find the oxidation number of sulfur in SO4 2 minus. Find the oxidation number of sulfur in SO4 2 minus. Now, if you look at this, this is no longer a compound. How did I know that this is no longer a compound? You could see ionic charge there. This ionic charge is minus 2. This ionic charge is what? Minus 2. Therefore, this is no longer a compound, but an ion. Now you're asked to find the oxidation number of sulfur in this ion. You do almost the same thing as we did for compounds. Permit me to check the network situation, please. Okay. To calculate the oxidation number of an element in an ion, you do almost the same thing as we did for compounds. The only difference is that in this case for ion, or in this case of ion, you are no longer equating to 0. If we equate to 0, you get into trouble. You fail the question. The reason is because, pay attention to this, you can put it down. The overall oxidation number of an ion is not 0. It's not. That is why you are always given the ionic charge. For compound, the overall oxidation number of a compound is equal to 0. But the overall oxidation number of an ion is not equal to 0. Rather, it is equal to the ionic charge given. And the ionic charge is also always written on top with either plus or minus, as the case might be. In this case, SO4, 2 minus. Now take note. This minus does not belong to this oxygen, because this is the area that some students might be confused. See that 2 minus you're seeing there? It is not for oxygen. As a matter of fact, this is something like this, SO4 in brackets. Then the 2 minus is the oxidation number of all these things together. So the ion put together, SO4, its oxidation number is what? -2. Which means that this -2 belongs to both oxygen and what? Sulfur here. So take note of that place. The -2 here is not the valency of oxygen. It's not. Anytime an ionic charge is given for an ion, that ionic charge written on top with either plus or minus belongs to all the elements in that radical. So let us solve it like I said. You follow the same pattern where you add up the multiplication of valency by atomicity for each element, and then you equate to something. But the something now is no longer 0, rather you are equating to the ionic charge. So here we are calculating the oxidation number of sulfur. We don't know. Permit me to use Y here. Then we come to that of oxygen. Valency of oxygen alone is -2. Take note, this -2 here is not the -2 that I have here. It's not. The atomicity of oxygen there is what? 4. In fact, let me put all this in brackets, and then I will fix 2 minus outside here. This 2 minus is the ionic charge. Then from here, we now apply our usual formula. Valency, oxidation number of sulfur, which we do not know, multiplied by the atomicity, which is 1 in this compound, add it to the oxidation number of oxygen here, which is 2 minus -2. Multiply it by the atomicity of oxygen in the ion. Then equate everything to the ionic charge, and the ionic charge is -2. You can see it, -2. If the ionic charge is positive, then you equate to positive of that number. But in this case, it is minus. Solve for y here and see. This becomes y. -2 times 4 will give you -8. Equate it to -2. Collect like terms. Y will now be equal to -2 plus 8, which will give you 6. So the value of y is equal to what? 6. Can now conclude, therefore, the oxidation number of sulfur in SO4 2 minus is +6. That is why in pronouncing this ion, we call it tetraozo sulfate 6 ion. You know, the first positive element that's meant to be here is not there. It's not there. So you don't have to pronounce it. For example, if it were to be something like calcium, it's a calcium tetraozo sulfate 6. But that positive ion is not there. Therefore, you move on straight to this element, determine the atomicity, Latinize it, change it to Latin word, which is tetra, then oxo. Sulfate 6 ion. Why ion? Why do we attach ion there? Because of this ionic charge. Let's check the network situation. Okay. We have 55 minutes gone by the time. But the interesting thing is that I'm really done with the main thing I want you to learn. How about we solve for one more? Let's solve for one more. Okay. So I'm going to wipe this. But I'm confident that based on what we've done, you see that this calculation is very simple. It's 1 plus 1. But you don't take it for granted, because it has a serious implication as you move on in chemistry. I've told you, for example, in the study of redox reaction, there is this titration experiment that is being carried out sometimes, redox titration, on this channel under our chemistry practical playlists. GMAETS for the ones channel, this particular channel, if you go to the playlist of this channel, locate our chemistry practical playlist, you would see a special video dedicated to redox titration. You need the knowledge of this calculation to be able to withstand redox titration. Exam bodies usually like asking that question in recent times, you know, WAEC, NECO, right? For those in university, at least those in UNIZIC, I'm aware that in your practical work, in your Chem 107 practical, yes, which your friends are going to do, those getting admission into 100 level, your first semester, you're going to do that course. You meet that redox titration as well too. So you see, you don't have to play. You need this calculation to guide you. Let us look at another question. Let us look at another question. We want to calculate the oxidation number of nitrogen. Find the oxidation number of nitrogen in NO3 minus. NO3 minus. This is the trioxonitrate. It's an ion. So what is the oxidation number of nitrogen here? Quickly. You follow the same format. Nothing is there. Nitrogen, we are looking for its oxidation number. So I'm going to use an unknown to represent the valency there. Go to oxygen. The valency of oxygen is 2 minus as usual. It's the same. And then the atomicity is 3. Let's enclose all this in brackets and then indicate the ionic charge so that you know that that ionic charge does not belong to oxygen. This minus 1, you'll see this minus is minus 1. So the valency of all these O3 is minus 1. It doesn't belong to oxygen only. From here, we apply our formula. This is going to be X times 1. The atomicity of nitrogen here is 1. Then we have minus 2 valency of oxygen times its atomicity equates to minus 1, the ionic charge of that ion. This becomes X. Simplify this, you get minus 6 equal to minus 1. Then collect like terms. Minus 5 we cross. As a pure number, it's going to meet minus 1 on the right-hand side. So that your X will be equal to minus 1 plus 6. Therefore, X is equal to plus 5. We conclude. The oxidation number of nitrogen in NO3 minus is plus 5. The name of this ion is trioxonitrate 5 ion, where that 5 is written in Roman numerals. I hope you enjoyed this class and I hope you've learned something wonderful. If you had not known how to calculate oxidation numbers of an element in a compound, I want to believe that this class has actually given you the expose, right? Has exposed you to it and broken down this concept. I also gave you a unique formula that will guide you, okay? Because that's actually the idea we use in solving this question brought up, right? That formula which I gave to you. But what are the things you don't need to joke with? Valency. Valency. And we've treated that. So if you have not learned about valency, please check back, in our previous classes and take the lesson. The knowledge of valency is obtained from valence electron. So if you want to really understand valency very well, start your study from valence electron. And when you talk about valence electron, what will help you out? You must know how to draw atomic structure. So you see how these guys are linked. Go and start from the beginning if you have a problem. On this channel, all the lessons you need to guide you up to this moment, up to this level, the video lessons are available for you. Now I'm going to give you one applied question. I'm going to give you one applied question where I will use it to ask you whether that element is acting as a reducing agent or whether it is acting as an oxidizing agent. After that question, we'll conclude today's class. Let me check the network situation. Yuki, is this CSEC chemistry? What level of chemistry is this? You know, I always have you friends ask the same question. This channel is dedicated to scholars, students from grade 10. In Nigeria, here we call it SS1. In some other country, you got grade 10. Are you following, right? It's high school level down to university. And one thing I want to tell you friends about, please, let us assume you are in grade 11 and you meet a concept where they are teaching something. If you are in science field, follow along. You may just learn something there. Are you following, right? So as long as you're a science student, forget about the level of this. Because I don't know a particular level I will attach it to. You know why? At grade 10, this is being introduced. That's actually the level it's been introduced. Sadly, many students do not have the opportunity of learning this stuff from that grade 10. Yes. Because I'm aware, especially if you come to Nigeria, chemistry is, although it's almost everywhere, but at least I'm speaking from the environment that I know well. Chemistry has always been a bottleneck to many. Because I don't know, is it because we don't have those who are really good at it? Or is it because those who are really good at it do not fancy teaching at schools? Or, you know, I just don't know. But you keep hearing students complain of this subject. But the subject is 1 plus 1. At least on this channel, I've started exposing the secrets gradually. So if you miss this at grade 10, you now have the opportunity to learn in grade 11, grade 12. In the university, it is also being taught. Yes, taught how. There are questions that you can be asked by your examiner where you are asked to calculate oxidation number. So do you see, you can't just attach this to any particular grade. But if we must, the kickoff is from grade 10. So ask yourself, have you learned this if you're in grade 10? If not, are you thinking that, okay, I'm in university now, 100 level, I don't need this? You are playing. You'll see questions on it in your examination. Please let us move on to our applied question. This particular question, I think is question 6 or so. This should be question 6. This one that I just solved should be question 6. Yeah. So we move on to question 7. This question 7 is going to be an applied question. It's going to be an applied question. Okay? It's going to be an applied question. Yuki, nitrogen valency is -3. Okay, let me adjust the camera and then say something from it. The valency of nitrogen normally, if you're talking about valency, is -3. That is why I said something that the idea of valency and oxidation number, they are closely related. As a matter of fact, I can say they are the same. Am I communicating? Valency of nitrogen is -3. But there are some cases that the valency of nitrogen will be +5. I had already explained that concept, I think, from part 2 of valence electron. Yeah, I've talked about that. It could be +5. And I explained that that happens when nitrogen reacts with a strongly electronegative atom. Because in that case, that strongly electronegative atom will overshadow the electronegativity of nitrogen. Thereby, that atom will not be negative, while nitrogen will become positive. And if nitrogen is to become positive, the valency of nitrogen will be +5. And that is why just cramming the valencies of this guy is not really sufficient to the concept of calculating oxidation number. It's not completely sufficient. Okay? You just have to know how to calculate oxidation number. And that is why we are having the class today. Let's move on to question number 7. I am going to give you a reaction equation. I'm going to give you a reaction equation, just a simple one. Sodium plus chlorine gives us sodium chloride. Sodium plus chlorine gives us sodium chloride. The question now is, which of the reactants is A, reducing agent, B, oxidizing agent. You know, in redox reaction, an oxidizing agent undergoes reduction, and the reducing agent undergoes oxidation. I am sorry, I'm not going to go deep into it in this class, because this is not the class that we are meant to treat redox reaction. I just want to open your eyes to something of how important this calculation of oxidation number is when you talk about redox reaction. Because it is under redox reaction you talk about what is oxidation, what is reduction. Are you following right? What is oxidizing agent? What is reducing agent? Now I want to tell you, some students have this challenge regarding this concept. And the reason is because they have problems with calculating oxidation number. Once you're very good with how to handle oxidation number and your teacher tells you the application, at least one use or more uses of oxidation number calculation, then coming to this concept of identifying reducing agent, oxidizing agent will become simple. To become what? Simple. Although generally in this reaction, sodium is referred to as the reducing agent, chlorine the oxidizing agent. But does it mean now that you start cramming, memorizing all the reducing agents, all the oxidizing agents? The truth of the matter is you can't even do that. You can't. You can't memorize all the elements that are oxidizing and all that are what? Reducing. Sometimes a full compound might be given to you. You could have a compound reacting with another compound to give you other products. And you are asked which compound is acting as an oxidizing agent, which one is acting as reducing agent. For example, I would tell you one, the reaction between acidified potassium tetraoxomanganate 7 and sulfur 4 oxide. You meet that under sulfur and its compounds. When potassium tetraoxomanganate 7, when potassium tetraoxomanganate 7 react with sulfur 4 oxide, you are asked which one is oxidizing agent, which one is reducing agent. So it all depends on your ability to calculate the oxidation number of the species there. Now let us find out how calculation of oxidation number can actually help us to determine which one is reducing and which one is what? Oxidizing agent. Before solving it finally, let me check the network situation. Yeah, because this is likely our last question. The network is still on. Answer. There's a solution. This time around, answer. Before I answer this question, let us assume I do not know. Let us assume I do not know that sodium is actually the reducing agent there and that chlorine is the oxidizing agent. Let us assume I do not know. What will I actually do to be able to find out the one that is oxidizing and the one that is reducing? I'll simply come here, determine or calculate the oxidation number here for sodium, do so for chlorine, come to the product and do same, then compare and see what happens to the oxidation number. Let's find out, please. For the reactant, let's look at sodium. Oxidation number of sodium is 0. Oxidation number of sodium equals 0. Remember, when we started this class, we explained that the oxidation number of a pure element, an element on its own, not in ionic form, that the oxidation number is 0. I just give you an element like this. You can see this sodium on its own like that. The oxidation number is 0. The same thing, oxidation number of chlorine is also 0. I'm sorry that I have to use this. You know the implication or what it means. Oxidation number of chlorine is also 0. That is for the reactant. Now let us go to the product now. For product, we are going to determine the oxidation number of sodium here and the oxidation number of chlorine here. This is a compound, so you must calculate the oxidation number. Are you following, of each of them? Because in this case, it's no longer 0. It's no longer 0. The oxidation number of an element in a compound can never be 0. Yeah, I don't think so. Oxidation number of a particular element in a compound can never be 0. The reason is because that element had reacted to find itself in that compound. And when something reacts to form part of a compound, it either gained or lost electron for that thing to happen. So the valency will no longer remain the same as it was from the product side, from the reactant side. For product, I'll come to sodium. Want to find out oxidation number of sodium. So let me indicate sodium. How do we get it? You come to that sodium chloride. Since we are looking for the oxidation number of sodium, I would indicate it as an unknown. And then oxidation number of chlorine, of course, valency of chlorine. So coming here, it implies that we are not going to calculate the oxidation number of sodium here. X times 1 plus, come to that of chlorine. Valency is -1. -1 times the atomicity, 1, because the atomicity of chlorine in this compound is 1. Equate it to 0. This is a compound, so it's going to be equal to 0. From here, clearly, if you calculate this, you find out that your result is going to be +1. Because this is -1 times -1 times 1 will give you -1. This is x already, x minus 1 equal to 0. Solve for x, you get 1. Do you observe something here? Oxidation number of sodium for the product is what? 1. Which means the guy increased. Yeah, the oxidation number of sodium increased from 0 in the reactant to 1 in the what? Product. Let us check for chlorine. Permit me to use, we are calculating for chlorine now. Now you getting me right? Which means that in this case, we are going to indicate the valency of sodium. Valency of sodium is +1. It's +1. Then you go to that of chlorine. We are looking for the oxidation number of chlorine. We don't know. So let me use Y to represent it. That's the oxidation number of chlorine. The implication is that we are going to get 1 times 1. That is valency of 1 for sodium times its atomicity in that compound, sodium chloride. You get 1 times 1, then add it to the oxidation number of chlorine here, which is Y times its atomicity. And the atomicity of chlorine is also 1. Equate it to what? 0. And you find out that Y will be equal to -1. Y will be equal to what? -1. Because 1 times 1 is 1. Plus Y times 1, which is Y. So you have 1 plus Y on the left-hand side equal to 0. Move that 1 to 0, you get -1. Now, did you see something here? Let me write on this side of the board as we conclude. I can say that sodium, oxidation number of sodium, oxidation number of sodium increased from 0 to +1. So this is +1, +1. And that of chlorine decreased from 0 to -1. You know that -1 is less than 0. Minus 1 is what? Less than 0. Let me check the network situation, please, as we conclude. Okay, good. And I think the left-hand side is showing. Let me adjust the camera a bit. Adjust the camera a bit. That's good. We're almost done. There is already 1 hour, 16 minutes or so. So let us round off. The fact that oxidation number of sodium increased from 0 to 1, and then the oxidation number of chlorine decreased from 0 to -1. We can use that to answer this question. Whenever I hear reduction is if any substance undergoes reduction, the oxidation number will reduce. If any substance undergoes what? Reduction. Take note of this, because I'm actually using this class to expose reduction and oxidation reaction for you now, pending when we are going to treat it, because it is not yet time for us to treat it, right? We still have other things to deal with. When the oxidation number of a substance reduces, that substance is undergoing what is called reduction. And like I told you, if any substance undergoes reduction, that substance itself that was reduced, that underwent reduction, that substance will become oxidizing agent. You see, this concept is a bit confusing if someone is not careful to understand it. Now look at me. I undergo reduction, for example. Something happened to me in a reaction and I was reduced, meaning I underwent reduction. Myself will now become the opposite agent, which is oxidizing agent. Once you understand this concept, you have grasped the secret of redox reaction. I was reduced. So the process that occurred to me is reduction. Therefore, I am the oxidizing agent. And like I said, when something undergoes reduction, how do you get to know? Using the knowledge of oxidation number calculation. The oxidation number of that substance will reduce. So if you look at chlorine, oxidation number of chlorine from 0 in the reactant to -1 in the product. So chlorine underwent reduction here. Hence, chlorine is the oxidizing agent. Chlorine underwent what? Reduction in this reaction, since the oxidation number decreased from 0 to -1. Because chlorine underwent reduction from 0, reduced to -1. That chlorine that experienced reduction, that chlorine that was reduced, becomes the oxidizing agent. If a process occurs to you, the agent that you will become is the opposite guy. That's just a trick. Now let us talk about sodium now. Oxidation number of sodium increased from 0 to +1. When your oxidation number increases, what is happening to you whenever you're talking about redox reaction is oxidation. So if you hear that, oh, this person underwent oxidation, this person was oxidized, how you will get to know is from the oxidation number. It will increase from the reactant. You're now moving to the product. The oxidation number is going to increase. Then you say that that guy has been oxidized. That substance underwent oxidation in the process. Now let me ask you, if something underwent oxidation, if something is oxidized, which is the loss of electron, because when you are losing electron, your positivity is increasing. You know, if you are losing electron, it's as if you are removing minus. And because you are removing minus, your plus value will increase. That is why in oxidation, when something undergoes oxidation, the oxidation number will increase because that thing is losing electron. Don't worry, we are going to play around with that when it is time for us to learn oxidation number. Let's just focus on this. Sodium, the oxidation number increased from 0 to +1. 0 in the reactant increased to +1 in the product. So sodium underwent oxidation. The process occurring to sodium in this reaction is oxidation. Sodium has been oxidized. Since sodium underwent oxidation, the agent that sodium now is, the name that you're going to call sodium here is reducing agent. Remember, oxidation occurred to sodium. Therefore, its name in terms of an agent it is in this reaction will be the opposite guy, which is reducing agent. Please, let's conclude. Therefore, sodium is the reducing agent. Reducing agent. And I told you because it underwent oxidation. And I explained the reason. Oxidation is loss of electron. And when you lose electron, your oxidation number will increase with regards to what? With regards to more positive value in you. Why chlorine is the oxidizing agent. Oxidizing agent. Oxidizing agent. Because of course, like we explained, chlorine was reduced in this reaction. Chlorine underwent reduction. So the agent chlorine is going to now be is oxidizing agent. Question now is, how did GMAT 41 get to know the answer to this question? Remember, the A part, which of the reactant is A, reducing agent? In fact, let me write A. Sodium is reducing agent. Why B? B, chlorine is the oxidizing agent. I simply got to know this based on oxidation number calculation. And as a summary to this particular guy, oxidation number increases in oxidation process. Oxidation number increases in what? Oxidation process. Why oxidation number decreases in what? Reduction process. At least you can fix that information in your brain. Once again, oxidation number increases in oxidation process. And oxidation number decreases in reduction process. When something undergoes reduction, you conclude that that substance has been reduced. Therefore, the substance becomes opposite, oxidizing agent. And when a substance undergoes oxidation, you conclude that that substance has been oxidized. Therefore, that substance in that reaction becomes a reducing agent. All of this knowledge from oxidation number calculation. What have we learned so far in our class today? We've learned how to calculate the oxidation number of compounds and of ions. We learned that in calculating the oxidation number of compounds, you want to remember that the total oxidation number, the overall oxidation number of a compound is equal to 0. While the overall oxidation number of an ion is equal to the ionic charge. To calculate the oxidation number of any element in a compound or in an ion, all you have to do is to multiply the valency of each element in that compound by its atomicity. Add all of them together and then equate to 0 if it is a compound you are dealing with. Or you equate to the ionic charge if it is the ion you are dealing with. And of course, for an ion, the ionic charge must always be shown, or is expected that you know it. We explained that the oxidation number of an element on its own, a pure element on its own, it has not reacted, it's always 0, just similar to that of a compound. And finally, we explained that the knowledge of oxidation number is vital to conquering redox reaction. So you want to understand reduction and oxidation reaction, excellent knowledge of oxidation number calculation is required. In conclusion, dear student, do not forget that all of these things are connected to valence electron, which exposes the knowledge of valency to us that we used in dealing with this topic. I'll be seeing you in our next chemistry class on chemistry. That is, we'll be dealing with chemistry next in our next chemistry class, which is next week's Wednesday, by God's willing. However, before that day, remember that we still have a live class on Friday where I'll be teaching you physics. We'll be looking at another dimension of physics, which is also further maths related. We'll be looking at another dimension of what? Physics, which is also further maths related. How to obtain the modulus of a vector in plane. You won't want to miss out in that class, because in that class we're also going to deal with addition and subtraction of vectors in 2 and in 3 dimensions. We're also going to look at how to obtain what we call the unit vector of a given vector in 2 and in 3 dimensions. Share these videos to your friends. If you come across any of GMAETS 41's lesson, please like the video, leave your comment, and share it to somebody. Someone out there needs it, so we can help ourselves for you to perform excellently well in your academics. I'll see you in our next class on Friday. Bye.